MSChauhan, a wonderful organic chemistry book for JE preparation. Let's see a few questions. The junctures centered on atoms A, B, C on the given structure. Fine. He is asking about the thing. Which juncture has the greatest deviation from the planarity? Okay. So, see, you can see this one because this is 1. He is saying this is 2. This is 3 and this is 4, which is having great deviation. You can see this is like T shape. So, greatest deviation from the planarity is C1. Of the carbon-carbon bonds shown above, numbered 1 to 4, which represent the most favorable site for hydrogen addition, which is less stable, that will be easily added. Less stable will be easily added. So, this is, as we discussed, this is less stable. So, this is your option. Okay, very, very rarely coming question. Don't worry much about this. Select the most stable structure on each of the following. More substituted alkene is more stable. So, in this more substituted, see here double bond, hydrogens are here. Here conjugation is there. This is isolated. They are not connected. 2 single bonds are there. These are also not. And moreover, this is very less substituted. And here conjugation is there. But hydrogen is here. Hydrogen is here. Less substituted. This is more substituted and conjugation. So, best. Correct, na? So, next. This is conjugation is there, fine. Here also conjugation is there, fine. Here no conjugation, so this is ruled out. This is isolated. Isolated, you forget about them. Now, see, more number of substitutions. Here 2 hydrogens are there. Here only 1 hydrogen, here only 1 hydrogen, much more substituted. So, B must be B. And in this case, conjugation, here allenes type, okay now. Allenes are less stable and this is again allenes, this is isolated. We need conjugated. Alternative double bonds is called conjugated. Conjugated is more stable. Stabilize like that. Match the column 1 with column 2. NO2 group. What is NO2 group? How it functions? See, NO2 is a minus M group as well as minus I. O minus is there, so it will be giving electrons, so plus M but minus I. Oxygen is having lone pair of electrons, so plus M but minus I. For cyanide, it is electron withdrawing minus M and minus I. So, which options are right? You just check minus M, minus I plus I. For A, it should be minus M, minus I means P and S. Then for B, plus M and minus I means Q and S. Oh, Q minus charge, na? When minus charge is there, it can give the electron pair. When minus charge is there, it is plus I effect. I forgot, sorry. Q and R. And when it comes to C, it is plus M and minus I. Plus M and minus I means Q and S. And last one is P and S. Plus M and minus I. Plus P and S. This point, don't forget. O minus is plus I effect. Very, very important point. CH3, match the column with dipole, cis trans type. Okay, na? See, very good question. Here this is boiling point, melting point. Okay, only 2 points. Generally melting point of trans is only more greater, boiling point of Cc is only greater. So there is no specialty in this. Let's go with this question. For A, cis dipole moment is greater. This is 1,3, no, simple, 2 butene. So melting point of trans is greater and boiling point of Cc is greater. Very regular point, regular question. Here comes the difference because of cyanide. Because of cyanide, this is dipole of trans is greater than cis. Okay, now so this is Q and melting point is greater R. Fine. Then coming to chlorine, same thing like cyanide only. So this is also Q and R. Here two sides chlorines are there. So no worries, same, it will be like PRS. Please check, this is one very interesting question. Okay, all differences are coming because these two are different. If by chance if cyanide group is here present, here chlorine is present, then all PRS are. Okay, in general, dipole of Cc is greater, melting point of trans is greater, boiling point of Cc is greater in general. But when two different groups are there, in this case it is reverse. Done. Thank you. Signing off. LR.